Hello friends, welcome to interview preparation session by 360DigiTMG. Okay, so let's see some questions on data science today. I hope I am audible to everybody. Yeah. So what's your first question is? So what does you understand by the term data science? So what does one understand by the term data science? Yes. Yes, friends. What does one understand by the term data science? So what is data science? In your chat box. So, what is data science, friends? Data science is an interdisciplinary field constitutes various scientific processes such as algorithms, tools, and machine learning techniques working to help find some common patterns and gather sensible insights from the given raw data. Okay, and we use statistical and mathematical analysis for this. Okay, friends. So what is data science? Data science is an interdisciplinary field that constitutes various scientific processes, algorithms, tools, and machine learning techniques working to help find some common patterns and gather sensible insights from the given raw data using statistical and mathematical analysis. Okay, friends? So, what are different steps involved in data science? So, the question is, what are different steps involved in data science? Yes, friends, you can answer in the chat box. Yeah, yes, Pinky. What are the 6 steps we have? So the question is, what are different steps involved in data science? I hope it is visible now, right? Okay, I have increased the font actually. So what are six different steps we have? Business understanding, yes. What are the 6 different steps we have? Data mining, data, where we clean our data. Data exploration, feature engineering, predictive modeling, and data visualization. So, yeah, actually the question was, I am asking about what are the different steps involved in data science. So it's not about crisp ML. Okay, friends, it's not about crisp ML. It's not so the question is not about crisp ML. Crisp ML is project methodology. Okay, how do we follow? Okay, question is about what are the different steps involved in data science. Difference. So we can say we have 7 different steps involved, which is understanding, data mining, data cleansing, data exploration, feature engineering, predictive modeling, and data visualization. Okay, so these are the 7 major steps we follow in data science, right? So when it comes to crisp ML, it is different. Yeah, whatever you have answered is correct, but it is related to crisp MLQ. Okay. So your next question is, so what is the difference between data analytics and data science? Yes. So what is the difference between data analytics and data science? So what is the answer? So what is the difference between data analytics and data science? Is part of data science. Yes. So data science involves the task of transforming data by using various technical analysis to extract meaningful insights using which a data analyst can apply to their business scenarios. Okay, friends. So whereas in case of data analytics deals with checking the existing hypothesis and information and answers questions for a better and effective business related decision making process. Okay, so usually we know, right? In data science, when it starts with data analytics, so we do data mining, data cleansing, data exploration. Okay, so these steps will be performed and the predictive modeling will be continued in data science. Okay, and yes, data visualization is also a part of data analytics. Okay, but when it comes to data science, so we do business understanding and we proceed with all these steps and along with data visualization also. Okay, friends. So, so your next question is, so what are some of the techniques used for sampling? What is the main advantage of sampling? Why do we sample? Why do we do sample? Sorry, friends. I guess there is a technical issue. Yeah. I hope you can see my screen. Right. So the question was, what are some of the techniques used for sampling and what is the main advantage of sampling? Random sampling clustering. Let's see. So in data analysis, the data analysis cannot be done on a whole volume of data. We know, right? What is whole volume of data? Population, right? So we cannot do our analysis on population at a time, especially when it involves larger data sets. Okay. So it becomes crucial to take some data samples that can be used for representing the whole population. Okay. And then we will perform our analysis. So we do not take whole population, but we take some part of data as sample. Okay. And we perform our analysis on this particular sample. Okay. While doing this, it is very much necessary to carefully take sample data. Okay. So it should be random, right? So we cannot take, so it becomes very biased if we take data in a normal way. Okay. So that is why we use sampling technique. Okay. We cannot take complete population data, but we take some data randomly. Okay, friends. So the question continuation is like, what are the two major categories we have in this? So there are majorly two categories of sampling techniques based on the usage of statistics. Okay. One is probability sampling technique, where we use such as clustered sampling, simple random sampling, stratified sampling. Okay, these are the different types of samplings we do using probability technique. Okay, so there are some sampling techniques that are done without probability technique also. They are called as non-probability sampling techniques, and we have examples such as quota sampling, convenience sampling, and snowball sampling. So these are some examples. Okay. So we have seen what is the importance of sampling and what are the different sampling categories we have. So the question was, what are some of the techniques used for sampling? Okay. And what is the main advantage of sampling? Right. So when there is a larger data sets, can you do your analysis on larger data sets? No, right? So what we do is we take random samples and we do our analysis on our data samples, and that will be inferred to our larger data set. Okay. So that is the advantage of sampling. Okay. And the question was, what are the different categories we have? So we have different categories based on the statistics we use. Okay. So in that we have two different types. One is probability sampling technique and the next is non-probability sampling technique. Okay, friends. So in probability sampling technique, we have clustered sampling, simple random sampling, and stratified sampling. So you have to work on these different sampling methods. Okay. And In non-probability sampling techniques, we have quota sampling, convenience sampling, and snowball sampling, etc. Okay. So the next question is, so we have overfitting and underfitting, right? So list down the conditions for overfitting and underfitting. Yes, friends, what are the conditions for overfitting and underfitting? So the question is, list down the conditions for overfitting and underfitting. Okay, let's see. So in overfitting, the model performs well only for the sample training data. Okay, if any new data is given as input to the model, it fails to provide any results. Okay, so that's the condition what we see in overfitting. So these conditions occur due to low bias and high variance in the model. Okay, so decision trees are more prone to overfitting. So this is very important. Okay, overfitting and underfitting. This question is very important. Okay, so what is overfitting? The model performs well only for the sample training data. Okay, if any new data is given as input to the model, it fails to provide any result. Okay, if we give any new data, it fails to provide any result. Okay, so it works on sample training data. Okay, so if we give the test data, it doesn't give us proper results. So these conditions occur due to low bias and high variance. Okay, friends, in the model. Okay, so decision tree are more prone to overfitting. Okay, so what is underfitting now? So what are the conditions for underfitting? Yes. So in this case, the model is so simple that it is not able to identify the correct relationship between the data. Okay, and hence it does not perform well even on the test data. So what we have seen in overfitting, it performs well on training data, but it does not perform well on test data. But in this case, it doesn't perform well on either training data or test data. Okay. So this can happen due to high bias and low variance. Okay. So these are the conditions what we have, right? Okay. So in underfitting, so the model doesn't work either on train data or test data. Okay. And why does this happen? This happens due to high bias and low variance. So linear regression is more prone to underfitting. Okay. So your next question is, so in evaluation we use p-values, right? So what does it mean when the p-values are high and low? So we use these terms in our evaluation process, right? What does it mean when the p-values are high and low? So the question was, what does it mean when the p-values are high and low? Let's see what it is. So what is the p-value? So a p-value is the measure of the probability of having results equal to or more than the results achieved under hypothesis, specific hypothesis, assuming that the null hypothesis is correct. So we are testing here null hypothesis in using p-value. Okay. So this represents the probability that the observed difference occurred randomly by chance. Okay. So here we are explaining null hypothesis using p-value. Okay. So what happens when we have low p-value, which means that it is less than or equal to 0.05. That means that the null hypothesis can be rejected. Okay. And the data is unlikely with true null. Okay. So this we mainly connect with null hypothesis. And when we have low p-value, which is less than or equal to 0.05, in that case, we say that null hypothesis can be rejected. So if it is greater than 0.05, it indicates the strength in favor of the null hypothesis. It means that the data is like with true null. Okay. So we take high p-value as a good sign. Okay. When the p-value is equal to 0.05 means that the hypothesis can either way. Okay. It can go either. So the next question is, so when is resampling done? So we have seen what is sampling, right? So what different categories we have. So when is resampling done? So the question was, when is resampling done? Sometimes we have to do resampling, right? If our data is not in a perfect condition. So the answer is, yes. So the resampling is a methodology used to sample data, okay, for improving the accuracy and quantify the uncertainty of population parameters. Okay, so it is a methodology used to sample data for improving the accuracy and quantify the uncertainty of population parameters. Okay. It is done to ensure the model is good enough by training the model on different patterns of a data set to ensure variations are handled. Okay. So if again we are taking the same pattern data and everything, so resampling doesn't work. Okay. So it should be ensured that the model is good enough by training the model on different patterns. Okay. So the same patterns what we have used in our previous sampling, we shouldn't use them. Yes, when we get the less accuracy. So to improve our accuracy, we do resampling. Yes. So what do you understand by imbalanced data? You have balanced and imbalanced data. Right? So what do you understand by imbalanced data? So what do you understand by imbalanced data? So it is important, right, to see whether our data is balanced or imbalanced. So any answers, friends? Okay. Okay, let's see what is balanced. So data is said to be highly imbalanced if it is distributed unequally across different categories. Okay. So these data sets result in an error in model performance and result in inaccuracy. Okay. So if our data is distributed unequally across different categories, like if we are working on default and not defaulters list, and we have 100 values, so it should be equally distributed. Okay, so the both categories whatever we have, it should be equally distributed. Okay, so if it is not, obviously if we have more defaulters data and we have less data that is related to non-defaulters, obviously it is imbalanced data. Okay, so that these data sets results in error in model formation and result in inaccuracy. Yeah, data is not equally distributed. Okay, friends. So next is, so we have expected value and mean value, right? So are there any differences between expected value and mean value? We know what is mean value and expected value, right? So are there any differences between the expected value and mean value? So question is, are there any differences between the expected value and mean value? So any answers, friends? Mean value is average value of data. So the answer is, yeah, you cannot find not many differences between these two, but it is to be noted that these are used in different contexts. Okay. So the mean value generally refers to the probability distribution, where the expected value is referred to in the context involving random variables. Okay. So you have to remember that there are not many differences we have, but mean value refers to probability distribution, whereas the expected value is referred to the random variables. Okay, friends? Yeah, mean value is the average value. Yes. Okay. So the mean value is related to probability distribution and expected value is related to random variable. Okay. So the next question is, define confusion matrix. Yes. So the question was, define the confusion matrix. Okay. So let's see what this happens. So it is a matrix that has two rows and columns, and it has four outputs that a binary classifier provides to it. Okay. So it is used to derive various measures such as specificity, error rate, accuracy, precision, sensitivity, and recall. Okay. So these are the different various measures that will be derived from confusion matrix. Okay. So your next question is, what is logistic regression? So your next question is, what is logistic regression? So what is logistic regression? Model is overfitting when using the logistic regression. Yeah, the question is, what is logistic regression? It's not that what's happening when we are using. So the answer is, so we can, how can we define logistic regression? Logistic So the question was, what is logistic regression? I think there is some technical issue in between. So the question was, what is logistic regression? And the answer is, Logistic regression is also known as logic model. It is a technique to predict the binary outcome from a linear combination of variables. Okay, so which are called as predictor variables. Okay. Okay, friends. So what is linear regression? So the question is, what is linear regression? So let us see the answer. So linear regression is a technique in which the score of a variable y is predicted using the score of a predictor variable x. Okay. So y is called the criterion variable. So what happens here? The score of a variable y is predicted using the score of a predictor variable x. Okay. So that is linear regression. Simple. Let's finish with one more question. It is also related to linear regression. So what are some of the major drawbacks of linear modeling? So the question is, what are some of the major drawbacks of linear? Yes, friends. So what are the major drawbacks of the linear model? So let us see this. So the assumption of linearity of errors is a major drawback in linear model. Okay. The second cannot be used for binary outcomes. Okay. So we have logistic regression for that. So for using binary outcomes, we have logistic regressions, but here we have only one variable y and we have predictor x. Okay. And we have also overfitting problems which cannot be solved. Okay. So these are the major drawbacks that we have in linear model. Okay, friends. So with this, we will close today's interview preparation session, and let us meet in next session. Okay. Thank you.